Okay, so welcome back to my YouTube channel. We are done with reproduction in animals, in which we talk about some of the terms in reproduction. We talk about ovulation, we talk about fertilization, copulation, and some other terms as well. We also talk about the functions of the male reproductive organ or system. Yes, so we talk about the testes, the epididymis, the penis, and the other functions as well. After that, we also talk about the functions of the female reproductive system or organ, where we talk about the vagina, the ovary, the fallopian tube, the vulva, the clitoris. We also learn their functions as well. After that, we solve a lot of questions concerning that topic. Now, we are coming to do a new topic. So our topic for the day is concept of diffusion. Concept of diffusion and its application in life. Concept of diffusion and its application in life. I think today is not the first time we are hearing the word diffusion. Yes. When I was in KG2, I did that topic. When I was in primary school, I did that one as well. In high school too, I did it. Yes. So this topic is what is not new to us. Diffusion. Yes. And how we can apply it in our daily life. How we can apply diffusion in our daily life. So first of all, what is diffusion? What is diffusion? If someone asks you, how can you explain the term diffusion? How do you explain it? Okay, so this is the right definition for diffusion. It says, diffusion refers to the movement of molecules from an area of high concentration to an area of low concentration until the molecules are evenly distributed. Yes. So it's the movement of molecules from higher concentration. Yes. The movement of molecules from an area or region of higher concentration to an area or region of lower concentration until the molecules are evenly distributed. Okay, so if you have a spray, then you stand at one corner and you spray that place. That place is highly concentrated. How am I getting it? That place is highly concentrated. For a few moments, that smell or that scent will get to the other end of the room. Yes. So at first, that other end was low concentration. Because if you can get the smell, it will be low. But where you were standing, that you spray there, that place is high. Because you can smell the scent so high, right? Yes. So it's the movement of molecules from a region of higher concentration to a region of lower concentration. Yes. So as I said, if you have a spray, you stand at one corner of the room and you spray there. Where you are standing is highly concentrated. Then the other end is lower concentrated. But for a few moments or for a few minutes, that one will also that place which was highly concentrated will extend to the other end. How am I getting it? Yes. If you are in a classroom and someone is in column 1, if the person will give a bad air, that column 1 will be highly concentrated. For a few minutes, those in column 5 will smell the scent as well. How am I getting it? Yes. So those in column 1, that place is highly concentrated. And the column 5 is lower concentrated. But for a few minutes, the smell from column 1 will get to column 5 due to the application of diffusion. Due to application of diffusion. Okay, let's continue. It says the driving force behind diffusion is concentration gradient. Yes. So I can bring this one to the exam. What is the driving force behind diffusion? And the answer is concentration gradients. So the driving force behind diffusion is concentration gradient. What is concentration gradient? What is concentration gradient? It says it's the difference in concentration between two regions. Yes, you know that you have two regions in concentration. The higher concentration and the what? Lower concentration. These are the two regions in what? That we have what? In concentration. And they are termed as what? Concentration gradients. They are termed as concentration what? Gradients. And before diffusion will occur, it depends on the what? On the concentration gradient. The higher concentration and the what? And the lower concentration. So before diffusion occur, one has to be higher concentrated, other one has to be lower what? Concentrated. So that it will transfer from the higher one to the what? To the lower one. So when you say concentration gradient, it's the difference between the higher concentration and the what? Lower concentration. So before diffusion will occur, it means you have one place which is higher. Maybe the smell is higher there, and other and the smell is what? Too what? Low. So you can check the difference. If you check the difference, one is having what? You can one place what? Having a high smell, other one is having what? A low smell there. How about getting it? Yes. So that's the difference. That's the difference. How about getting it? Yes. So when I talk about the concentration gradient, it's the difference between the higher concentration and the lower concentration. These are the two regions we are talking about. So assuming your mom is cooking, then you are outside, you can hear the smell, maybe small one. How about getting it? So that will be your lower concentrated. And when you get inside the kitchen, that is your higher concentrated. So before diffusion occurs, there's what difference between these regions, the higher one and the lower one. But very soon, the higher one will extend to the lower one, and you have a uniform mixture, right, of the sense as well. Okay, so that's the driving force behind concentration. Okay. Now, it says diffusion always tends to equalize the concentration gradient. Diffusion, it tends to equalize the concentration gradient. Yes, as we said, the concentration gradient is the difference between the higher concentration and the lower concentration. But when diffusion occurs, it tends to equalize it. Because when diffusion occurs, it will spread the whole room. How are we getting it? Yes. So, as I said, if someone in column 1 give a bad air in column 1, those in column 5 will not smell that one. How are we getting it? It will take a few minutes before it will get there. So when that person gives a bad air in column 1, the difference, that person will be highly concentrated. The difference between the higher one and the lower one is the what? Is the concentration gradient. But for a few minutes, it will spread the whole room. How about getting it? So when it's spread, diffusion, it tends to equalize what? Equalize the what? The concentration gradient. Now you cannot measure the difference. How about getting it? You cannot measure the difference between these regions. It will be the same. How you smell the scent from that. It will be like someone who is in column 5. How the person will smell the scent. It will be like someone who is in column 1. Right? Now it will be the same. Meanwhile, the person who gave out the bad air is in column 1. But it will be the same. So diffusion, it tends to equalize the concentration gradient. How about getting it? Yes. So first of all, the concentration gradient, higher one and the lower difference between it. But diffusion, when it happens, the whole room will be highly concentrated. You have uniform smell. You have uniform smell. The same thing. One will not be higher, another one will not be lower. It will affect all of them. From higher one to lower, then to equalize it. Are you okay? Okay. So that is the meaning of diffusion. That's what the meaning of diffusion, or the definition of what diffusion. And the driving force behind it is the system as well, the concentration gradient. And we also learned that the diffusion, it tends to equalize the concentration of gradient. Thank you. Okay, so now we know the definition for diffusion. We are coming to perform and what experiment. You have two experiments to perform. Yes. Okay. So our first experiment, the title, it says demonstration of diffusion of potassium permanganate Yes, demonstration of diffusion of potassium permanganate. The potassium permanganate is like a small crystal. That's how the salts look like. The big one, those from the villages, the salts. We have the big ones and the smooth one. Yes. I have to maybe show you some, but let's continue. Let's continue. I hope you know the salts, the big ones. The big ones. So that's how potassium permanganate crystal looks like. Okay. So we are using that one to perform an experiment to explain what? Diffusion. To explain diffusion. Potassium permanganate crystal. As I said, it looks like the salt, the big ones. Okay. Now, this is the title of our experiment. The title of our experiment. Okay. So, demonstrating the speed of permanganate ions in solution. Yes. So, the potassium permanganate crystal. We are doing the experiment to demonstrate the speed. That's what it was. It will spread in the what? In the solution. Yes. We are performing the experiment to demonstrate the speed. That will take the potassium permanganate to spread in the what? Solution. Are you okay? So that's the title of our experiment. That's the title of our experiment. Now, let's come to the aim. As I said, the aim, it means the purpose of the experiment. The purpose of the experiment. Okay, so the purpose of this demonstration is to show how particles move from an area of high concentration to an area of low concentration. Yes, so the purpose for this experiment is what? Is to demonstrate how a particle will move from an what? Area or a region of higher concentration to what? A region of what? Lower concentration. Yes. So definitely, you know that if you put maybe sugar inside water, it will move from what? From a high concentration to a low concentration. The place that you put the sugar there, the water, the place that you put the sugar there, it was having what? Higher concentration. But for a few minutes, it was spread, and it will create the solution as well. Yeah, so that's the aim or the purpose of our experiment. We are performing the experiment to demonstrate how particles are able to move from higher concentration towards an area of what? Lower concentration. Okay. Now, what are some of the materials that you need for the experiment? Materials needed for the experiment. Materials needed for experiment. Take a critical look at this. During the midterm exams, I gave you some of the practicals and I asked you to provide some of the material used for that experiment. Some people were drawing a certain table that I don't know where it's coming from. Just give me two materials each for those experiments. You were drawing. And some also giving me table of values. I don't understand. Okay, let's continue. So materials needed for this experiment. Material that you use for the experiment. Okay, so you have the beaker. Yes. You have the beaker that you put the water inside. The normal beaker that you put the water inside. Then water. Water. Yes. So you will also need water as well for the experiment. Then potassium permanganate crystal. Yes, as I said, potassium permanganate crystal. That's the main material for this experiment. The main material for this experiment. Crystal is look like salts, the big ones. Okay. Then you have a spatula as well. Spatula. If you go to lab, you can see the spatula there. It look like a spoon. So use it to pick the potassium permanganate crystal, and you put it inside the water. Yes. So that's what spatula. That's what the spatula. Okay. So these are the materials we are going to use for the what? Experiment. Beaker, water, potassium permanganate crystal, and spatula. In exams, if I ask you to state any two materials for this experiment, don't go and draw anything for me. Okay. Now let's come to the procedure for the experiment. Procedure for the experiment. Okay, so proceed. I'm reading from here. I hope you have the slides as well. Okay, so I'm reading from here. Okay, so the first method, it says fill the beaker with water. Yes, so this beaker, you fill it with what? With water. So water is not expensive. You can perform this experiment in your various houses. Yes, in various houses. So water is not expensive. You can take a small bowl, yes, and use it as your beaker for this experiment. Yes. So after this one, you can try this experiment at your various houses as well. Okay, so fill the beaker with what? Water. So first of all, we fill the beaker with water. Okay, so that's the first one we will do. Okay, second one, it says put a piece of potassium permanganate crystal into the bottom of the beaker containing water using a spatula. Yes, so it says put the potassium permanganate crystal inside the water using what? The spatula. Yes, so you use the spatula to pick the potassium permanganate crystal and put it inside the water, inside the beaker which contains the water. Okay, I hope I get it. Now, the third point says observe what happens over a few minutes. Observe what happens over a few minutes. Yes, so for a few minutes, maybe 2 to 3 minutes, observe what happens. Observe what happens. So what will happen? If you put the potassium permanganate crystal inside the water and you observe it for a few minutes, maybe 3 minutes, and you come back to observe it, what will happen? And as I said, potassium permanganate crystal is like the salt, the big ones. So what will happen? As we are using salt, the big ones, to perform this experiment, what will happen? Then you put inside a beaker which contains water, and you come and observe it within 3 minutes time, what will happen? Okay. So you have a crystal of dye is placed in water, so the potassium permanganate crystal is placed in water, right? Yes. Then diffusion of water and dye molecules, you can see that they are spreading. They are spreading inside of the beaker. It's spreading. Okay, it's a process. Then definitely it will have what equal distribution of molecules. Yes. So for a few minutes, it will have equal distribution of what? Of molecules. So the first question that I asked you, that what will happen? What will happen? So observation. When potassium permanganate crystal is placed in water, the crystal dissolves and the permanganate ions are concentrated in one area. Yes. Okay, so observation is trying to tell us that the potassium permanganate crystal will dissolve and it will occupy the whole space as well. You can see that it is here, but it will dissolve. Observation, for a few minutes, it will dissolve and occupy the whole space. Thank you. Okay, so as I was saying, observation, when potassium permanganate crystal is placed in water, the crystal dissolves and the permanganate ions are concentrated in one area, or it will occupy the whole space. So that's what the observation for the experiment. The potassium permanganate crystal, it will dissolve. Then it will occupy the whole space. It will occupy the whole space. As you can see it here, it was able to occupy the whole space. It will dissolve and occupy the whole space. Like this one. First of all, it will be like this one. Then it will dissolve. Then it will occupy the whole space. Yes. Okay. Now, what will be the conclusion for our experiment? Permanganate ions move from an area of higher concentration to an area of low concentration until the ions are evenly distributed. Yes. So you can see that this space is highly concentrated when you put the potassium permanganate ion or crystal there. Yes. Then here is what? Lower concentrated. Yes, highly concentrated because here is where the potassium permanganate crystal are. Then here is lower concentrated because you don't have any potassium permanganate crystal here. So here is lower concentrated. Yes. So finally, it will dissolve and it will what? Distributed equally inside the what? Inside the what? Inside the beaker. So that's why we are saying that our conclusive permanganate ion move from an area of high concentration to an area of low concentration until the ions are what? Evenly distributed. Yes. So the ions will be evenly distributed. It will be distributed. It will occupy the whole space. It will not occupy just here. At first it was just here. Finally, it will occupy the whole space of this one. From high one to what? To the low one. So high one to the low one is what? Have uniform mixture or uniform what? Distribution. So that is the experiment. So you can either use salt or even sugar, the cube one, sugar the cube one, and use it to perform the same experiment. Just 3 procedure, right? Just 3 procedure. You'll be able to finish the practical. Because first of all, you put water inside the beaker. Second, you can put your potassium permanganate crystal or the salt that you're going to use for the experiment or the cube sugar that you're going to use for the experiment inside the beaker, which contains the water, right? Then the third one, observe what will happen. The third one, observe what will happen. I think this one is going to cost you anything, so you can try this experiment at your various houses. Are you okay? Okay. So thank you for enjoying today's lesson. You continue the lesson next week. Have a good day. Bye bye.